Alright, so this is where we reached in the last video. We're looking at CSEC Mathematics, January 2024, and we are at question 8, part B. We did part B1 in our last video, and now we're looking at part B2. So, we should sketch 4x squared minus 24x plus 31. What we did before was to write 4x squared minus 24x plus 31 in the form ax plus a squared plus k. Now we got this 4x minus 3 squared minus 5. Now, if you remember this well, what you would, let me copy this graph and put it over here. Alright, so what you would have 4x minus 3. Now the thing is, the graph of x squared will look something like this, right? That's the graph of x squared. When we say x minus 3, we'll shift the graph to the right, 3 places to the right. So it would go to the right 3 places. So it would end up over 3. And then minus 5 means it would go down 5 places. Right? Beside negative 5. Okay? And then multiplying it by 4 would make it steeper. I mean, if this is x squared, this is x minus 3 squared, it goes to the right 3 places, then that minus 5, it pull it down in the y direction, it would be downward 5 places. If x squared look like this, then 4 times x squared would look more like this. It would be steeper, right? So when you sketch the graph, it would look more something like this. Let me erase these. These would be just rough work, right? So it might be something like this, alright? My. Let me erase this part. But anyway, I don't think the base would be so sharp though, right? So let me just do another sketch of it. Probably more like this, whatever it looked like. Now, in order to find out exactly where it cuts the x-axis, we would have to solve this equation here. But the thing is, they did not ask us to solve it, and they gave only 3 marks. Right? They gave 3 marks. They say indicating the coordinates of the maximum or minimum point slash minimum is either maximum or minimum point of the y-intercept. Okay. No. Minimum point and the y-intercept. Okay, those are what they want. The minimum point. The minimum point would be negative 5. So the negative 5, right? So y would be negative 5. Let me write it here. And they want the y-intercept. Alright, how would you get the y-intercept? At the y-intercept, x is equal to 0, right? So when x equals 0, we would get 4, 0 minus 3 minus 5. No, 0 minus 3 squared minus 5. So we get 4 times 9 minus 5. 4, 9, 36. 36 minus 5 is 31. So it will be 30. Why I put the negative here? Right here will be at 31. Alright. Now, how about we plot the original function using the computer itself and see what it looks like, if it really looks like this. You have 4x squared minus 24x. I have GeoGebra graph plotter here. So I'm going to type in 4x raised to the power of 2 minus 24x. And what else happened after this? Plus 31. So we say plus 31. Alright. This is what we have. Let me change up. Alright. Make it thicker. I want to show the equation on it to show you that what I really have is 4x squared minus 24x plus 31. 4x squared minus 24x plus 31. Alright, so let us look at certain parts of this graph. If you zoom in here, you can see that the minimum point is right there at y equal negative 5. Alright? Now this line, what does it line up with? It is 3. So it is, the minimum point is below 3 and beside negative 5. What about the y-intercept? I said it was 31. We'd have to go all the way up here and see where the curve intersects the y. Let's zoom in. We see 31 there. Aha, it is 31. So, you see that our graph was indeed the graph that we should have. Right? So it was indeed correct. We're zooming out at this to take a look at the whole graph. So that's what we have. To see these, again, we'd have to zoom in to see the values here. Alright, so that is the graph that we have. What else do they say? State the equation of the axis of symmetry. Well, looking at it, the axis of symmetry would be what? What do you think? It will be x equals 3. It will be this line here. Let me draw a straight line. It will be this line. Every point on this line, x is always equal to 3. No matter what y is, at this point x is 3, x is 3, x is 3, x is 3. X is always equal to 3. Alright? Wherever you go on the line, x is 3. So x equals 3 is the equation of the axis of symmetry. And remember, the axis of symmetry, it divides the shape, the graph, into two halves so that when you fold them over the axis of symmetry, they match. In this case, the name of the graph we have is a parabola because it's a quadratic graph. That is it for question 8. So, next time we look at question 9.